Okay, class, you want to prepare for Circles Day 1 by turning in your packet to the pre-lesson assignment for Circles Day 1. Okay, it's 2 pages. You're going to fill out both pages for homework tonight. Most of what you're going to see tonight in this video is things that you should already know about circles. Okay, so let's get started. First of all, circle is the set of points equidistant from a given point called the center. Okay, so let's look at the circle I have on the board. Let's call it circle C. We'll name the center C. All these points on the circle are the same distance from that center point C. We always name a circle by its center. Okay, so we would call this circle C. Or shorthand notation, you just draw a small circle with the center in the middle and then the letter of the center after it. So each of those says circle C. The next thing we want to talk about is a diameter. A diameter is a segment going through the center of the circle with both endpoints on the circle. Okay, let's call this diameter AB. You can see endpoints are on the circle and it goes right through the center. After that, we need to talk about a radius, which is a segment connecting the center of a circle to a point on the circle. So for example, maybe we have radius CR. Okay, it connects the center to a point on the circle. The relationship between a diameter and a radius is that the diameter is equal to 2 times the length of the radius. If you look at our diameter AB in this circle, you can see that CA is a radius and CB is a radius. So therefore, 2 radii make up that 1 diameter. Okay? Note that any radius of a circle should have the same length. Since all those points are equidistant from the center, any point on the circle that would connect a radius is going to be the same length. So for example, if I draw a radius CT in here, CT, CA, CR, CB all have the same length. All radii of a circle are congruent. Let's take a look at the examples. It says use the diagram to answer each question. So you've got a diagram. It's circle Q. You've got that QR has a length of 3.6 and that QP is another radius. Part A, what is the length of the diameter? Well, we can find the diameter by taking 2 times the length of the radius, 3.6, which gives us the diameter of length 72. Name the circle using shorthand notation. We're going to have circle Q. And C, name a radius of the circle. You could either say QP or you could say QR. Either answer would be fine. Next vocabulary word. A chord is a segment with both endpoints on the circle. Okay, so a chord, let's go back to our original diagram here. I'm going to draw in chord DE. It's a segment. It has both endpoints on the circle. Okay, it doesn't have to go through the center. It just has to have both endpoints on the circle. Okay? You can see, because the diameter has both endpoints on the circle, that a diameter is a special type of chord. Okay. Last thing in terms of vocabulary to talk about is the circumference. The circumference is the distance all the way around the circle. So if I measured that and I found, let's say, I don't know, it's 18 inches. Okay, then the circumference is 18 inches, the distance around the circle. Okay, the formula is circumference, C, equals 2 pi r, where r is your radius. Okay? Or, since we know that 2 times the radius is equal to the diameter, we can say that the circumference is d pi. Okay? Either one of those formulas will work just fine. 2 pi r or d pi. Example, solve the problem. What is the circumference of a circle with radius 4 meters? Okay, if we're given the radius for our example problem, okay, write out our formula, C equals 2 pi r. We are going to fill in our radius, so 2 pi times 4. 2 times 4 is 8, so we've got 8 pi. Or you can multiply that out in your calculator. You should have a pi button on your calculator. If your calculator does not have a pi button, you can substitute 3.14 in for pi. When you multiply that out, 8 times the pi button, it's going to give you approximately 25.13 units. Okay, there's our circumference. Let's flip to the next page. On the next page, the first thing we're going to talk about is an arc. Okay, the arc is a part of the circle or a portion of the circumference. If you look at the diagram to the bottom right of arc, it's circle U, and points V and T are on the circle. If I highlight the portion of the circle between V and T, that would be an arc on the circle. Okay? It's literally a portion of the circumference. Think about having a donut and breaking a piece off. That piece of that donut has an arc. Okay? We notate an arc with letters and an eyebrow over the top. So for example, I would call this arc VT, and then I put a little eyebrow over it. Okay? That's how we read arc VT. Just like segments, we can also call that arc TV. A central angle is an angle whose vertex is on the center of the circle. So if I connect radii UT and UV in our picture, what we've got is central angle VUT. I know it's a central angle because the vertex is right on the center. An intercepted arc is the arc created by the endpoints of an angle on the circle. So, intercepted arc are created by the endpoints of an angle. Okay, here are the endpoints of the angle on the circle. Okay, so the intercepted arc is the arc falling between those two endpoints. So in this diagram, our intercepted arc is arc VT. Okay, I always like to think about football. Shocker. Okay, in football, you make an interception, you want the ball to be between your hands so you can make that interception. In geometry, we want the arc to be between the sides of the angle to be our intercepted arc. One thing that's important that we need to note about a central angle is that a central angle has the same measure as its intercepted arc. Okay, so if this angle has a degree measure of 72 degrees, then the degree measure of this arc is also 72 degrees. In terms of notating that, you would just say measure of arc VT equals 72 degrees. Let's do some examples. Use the diagram to name the intersected arc for each angle. I'd like you to pause the video here and try and name the intercepted arcs on your own. I'll read the answers in a minute so that you can figure out if you did it correctly or not. Okay, so you must have checked your answers and unpaused the video. The intercepted arc for angle XWZ was arc XZ. The intercepted angle for the intercepted arc for angle ZWY was arc ZY, and the intercepted arc for angle YWX is arc YX. Number 10. Sum the central angles. If all non-overlapping central angles of a circle are added together, the sum will always be 360 degrees. Hopefully you know that a circle makes 360 degrees. All this is saying is that if I have a circle with several central angles, okay, maybe all different measures, let's call them angles 1, 2, 3, and 4 in this case. I can add all those central angles together, measure of angle 1, plus measure of angle 2, plus measure of angle 3, plus measure of angle 4, and they should always add up to 360 degrees. Okay, that's going to take us into some special kind of arcs. We're going to talk about 3. The first is a major arc. Okay, a major arc is an arc measuring greater than 180 degrees. That's major arc, greater than 180 degrees. Okay, when we talk about major arcs, we're going to name it with 3 letters. So let's take a look at that diagram that you've got on your paper. Okay, we've got circle A, diameter CB. I know it's a diameter because it goes through the center, and radius AD. Okay, in the diagram, a major arc, again, we want to name an arc with 3 letters, and we want it to be bigger than 180 degrees. Okay, so for example, I wouldn't want to call arc CDB, because that's exactly 180 degrees, starting at C, traveling through D, and ending at B. However, if I name this arc CBD, that middle letter tells me direction. So I'm going to start at C, go through B, and end at D. So we want to call a major arc, example, will be arc CBD. And again, you want to put that eyebrow over top. Okay? Middle letter determines direction. Determines direction. Okay, why do we use 3 letters to name an arc? Exactly what I just explained. So that way we know the direction that we need to go to our endpoint. A minor arc is an arc measuring less than 180 degrees. Okay, so minor arc is going to be less than 180 degrees. So if we look again in our picture, this time we need an arc to be less than where the diameter is. So again, we don't want CB as an arc. We certainly don't want CBD, but arc CD would be a great example. So an example of a minor arc in the diagram would be arc CD. Okay? You'll notice it has the same starting and ending point as our major arc, but it went in a different direction. You only need 2 letters to name a minor arc. Sometimes you'll see in the book they're going to use 3 letters, but you only have to have 2. A semicircle is an arc measuring exactly 180 degrees. Semicircle measures 180 degrees. Semicircle is created by the endpoints of the diameter. Okay, so here are our endpoints of our diameter. So a semicircle would start at C and go to B. Okay, it would go either direction, would be a semicircle. Okay, I would use 3 letters to name a semicircle. So for example, CDB, telling me to start at C, to go through D, and end at B, would be a good example of a semicircle. If you ever need to name a semicircle and there's no 3 letters, you can always put an auxiliary letter on. Just pick another letter that's not there. For example, F. CFB would be another good example of a semicircle. All right, last example. Use the diagram to name a major arc, a minor arc, and a semicircle, assuming segment ON is a diameter. Go ahead and try now, and then I'll read the answers. Pause the video. I'm assuming you paused the video and you've got your answers for a major arc, minor arc, and a semicircle in the drawing. Okay, a semicircle would be OMN, arc OMN, or if you put an auxiliary letter on the other side, that would be okay too. A minor arc would be arc OM, and a major arc might be, for example, MON. That would be a good example of a major arc. Okay, that's it for Circles Day 1. Make sure you understand this and have any questions prepared when you come to class tomorrow. If there's something you didn't understand, go back and watch that part of the video again. If you still don't understand, write your question down so you can ask as soon as we start tomorrow morning. Have a great night.